Hey guys, welcome to CodeStreak Daily. So, in today's video, we'll solve a very interesting problem. We have to find the maximum width of a ramp in an array. So, let me read the description here. Before that, it's a medium level difficulty problem. And coming to the description, a ramp in an integer array, the array name is nums, is a pair ij where I less than j and nums of I less than equals nums of j. The width of such a ramp is j minus 1. So we have to find I and j where I will be less than j and nums of I will be less than or equals to nums of j, and we have to return j minus I. So given an integer array nums, we have to return the maximum width of a ramp in nums. If there is no ramp in nums, we just have to return 0. Okay, now let's go through the example. We have a array nums and the elements are 6, 0, 8, 2, 1 and 5 and the output is 0. Let's see the explanation. The maximum width of ramp is achieved at ij 1 and 5. So let me count the index as 0, 1, 2, 3, 4 and 5. So the first index is 0 and the fifth index is 5. Nums of 1 equals 0 and nums of 5 equals to 5. 5 minus 1 equals to 4. We also have another example. Nums contains these many elements and the output is 7. Here ij are 2 and 9. Nums of 2 equals to 1, this one, and nums of 9 equals to 1. So we have to return 9 minus 2 equals to 7. Okay, here we have to check the maximum values of I and j, not nums of I and nums of j. Okay, for this example, you may think that here we have the value for I equals to nums of I1, that is I equals to 1 here, nums of 1 equals to 0, and we have 8 here, nums of 2 equals to 8, and we may think that 8 minus 0 equals to 8. No, that's not how it works here. Here we have to talk about the index values. Okay, we don't need the values of the array, we just want the indices where the maximum width of the ramp can be achieved. Okay, here in this the smallest element is 0, so nums of 1 equals to 0, and in this largest element is 8, but here the nums of 8, the nums of 3 or 0 1 2, sorry, nums of 2 will be 8. So if we check 2 minus 1, we will get 1. Let me write down here, you will get clear understanding. Here I equals to 1, where the value is 1. Okay, j equals to 2, where the value is 8. So we have to return j minus I. So the value will be 2 minus 1 equals to 1. But if we check I equals to 1, the value will be, sorry, the value will be 1, whereas j equals to 5. For this, the value will be 5. Here we have to check the values of j minus I. J minus I equals 5 minus 1 equals to 4. Okay, this is how we have to check the values of the indices, where we also have to check I less than j as well as nums of I less than equals to nums of j. We have to check the values for both I and j and as well as the nums of I and nums of j. Both the conditions has to be satisfied and the maximum width should be identified. Okay, I hope you understand that. Now let's talk about the approach how to solve this problem. So we will use a monotonic stack. Now let me break down how we are going to solve this. The idea here is to use a monotonic stack to keep track of the potential left side candidates I. Then we'll check for the right side candidates j, and we'll calculate the width as we traverse the array from the end. Okay, now let's see this in detail. Now let me move on to writing the code to implement this approach. We will use a two-step process. First, we will build the stack, and second, we will find the maximum width of the ramp. Okay. In first step, Here I am going to create a stack to store the decreasing sequence of the indices. So I am writing stack and I am creating an empty stack here. Then I am going to traverse the array and add the indices of the decreasing sequences to the stack. So I am taking a for loop for I in range of length of nums until the end of the array. So I am checking that if stack or not, or nums of I, what we have to check the decreasing thing, right? Less than nums of stack of -1. So in this condition we are appending stack dot append of I. Okay, so we are going to traverse the array and add the indices of the decreasing sequence of the stack. So in this step we created an empty stack. The purpose of this stack is to store the indices of the decreasing sequence of the numbers. But why decreasing? Because these are the only indices that can potentially serve as the left endpoint I in a valid RAM. Then we loop through the array, and if the current element is smaller than the one at the top of this stack, we add its index to the stack, and if the stack is empty, we add the current index as well. Okay, now we have to find the maximum width. Okay, we have to find the maximum width. Now I'm initializing the maximum width, max underscore width equals to 0. Now I have to traverse the array from the end and try to find the maximum width for the ramp. Okay, for j in range of length of nums -1, length of nums -1 comma -1 comma -1, because here we are traversing the array end from the end of the array to the starting of the array. So I'm taking like this. I'm taking a while loop here, while stack and nums of j. Here we have to check the greater than equals to nums of stack of -1. Now we have to calculate width and we have to update the maximum width. Okay, max underscore width equals to, we have to take the maximum value, max underscore width comma j minus stack dot pop. We have to take the top element. Okay, and let me tell you what I have done here. In this step we are traversing the array from right to left to find the maximum width ramp. For each element nums of j, we check if it can form a ramp with any index in the stack. If nums of j is greater than or equal to nums of stack of -1, then the index at the top of the stack left can be the left end point I, and j can be the right end point. Then we will pop the index from the stack and calculate the width j minus I, updating the maximum width if needed. Okay, now we have to return maximum width. Okay, now let me try to run the code and check if that works or not. Okay, okay, there's a typo. Let me run the code again. Oh, I don't max underscore width. Okay, uh, the typo is here also. Yeah, as you can see here, both the test cases are perfectly working fine and the code is accepted and the runtime is 26 milliseconds. Let me submit the code and check if all the test cases will be working fine or not. Yeah, as you can see, the code is working perfectly fine and it beats 38.45% of users, and we have runtime of 359 milliseconds. Okay, so this is where we are. Only there are 5.93% of solutions use this runtime. So this is today's Leetcode problem. Now let's analyze the time and space complexity of the solution as well. Okay, the first loop that builds the stack, this loop takes the order of n time, and the second loop to find the ramp also takes the order of n. So the overall time complexity will be order of n only, where n will be the size of the array. And coming to space complexity, the stack can store at most order of n indices, so the space complexity will also be order of n. And that's how we solve the problem of finding the maximum width of a ramp in an array. Thanks for watching, guys. If you found this explanation helpful, make sure to give this video a thumbs up and leave a comment below. Also subscribe to CodeStreak Daily for more daily coding solutions and explanations. If you have any queries or if you find any more efficient code than this, please do put that in the comment of this video, and I'll surely check on that. So hit the bell icon after you keep subscribing, right? Keep streaking daily, guys.